In this presentation, we will discuss leak detection. First, let's define a leak. A leak is capable of flowing gas from one side of an object to the other. A leak can be a space between a mechanical joint, material or weld porosity, or permeable material such as elastomers and polymers used for sealing. Everything leaks. The question is, how much? And is it an acceptable and safe rate? That rate is called leakage rate, and it quantifies the volume of a given gas for a given amount of time. There are three leak flow directions that are tested in valves and regulators. An inboard leak is simply a leak from atmosphere into the internal volume. An outboard leak is a leak from the internal volume to atmosphere. A leak across the seat is an internal leak across the seat from the inlet to the outlet side. Inboard, outboard, and across the seat leaks are tested to ensure leak-tight operation. Some leaks are more easily detected with one method versus another, so many leak test methods are performed on each part. In the semiconductor industry, a helium mass spectrometer is the most common type of leak detector. It uses vacuum to detect leaks. The mass spectrometer can detect very low levels of helium, some down to parts per trillion, or 1 × 10⁻12 concentration of helium. Its internal vacuum pump and vacuum chamber pull vacuum and draw in helium. Helium is used as the tracer gas because its small molecule size passes through leak paths more easily than larger molecules. Helium is also non-hazardous and has naturally low concentrations in the atmosphere, typically about 5 × 10⁻⁶. This allows for good sensitivity when leak testing for an external leak into atmosphere. Time and pressure differential are needed for the small volumes of helium to pass through a leak path and be detected. The other common method of leak testing is static leak testing. It uses positive pressure to detect leaks rather than vacuum. This method traps pressure in a valve or regulator and tests for an increase or decrease in pressure over time. Static leak tests can find outboard and across the seat leaks. The difference between the starting and ending pressure is measured. For example, a part may be tested to less than 0.2 psi decrease in pressure over 6 hours. The trap volume, test time, and pressure sensor resolution determines the static leak test sensitivity. Ambient temperatures will have an effect on internal pressure, so temperature compensation is required for the highest accuracy. With helium leak testing, it's important to note the difference between an across-the-seat leak and a seat permeation leak. A seat permeation leak is a leak through the seat material. A permeation leak will be detected quickly after seat exposure to helium. Even if the seat is sealing normally, a permeation leak will be detected in 30 seconds or less. Common seat materials are easily permeated by helium in 30 seconds exposure time. APTech recommends that an across-the-seat leak test is completed within 15 seconds or less to avoid detection of a permeation leak. Now let's review the specific leak testing methods and their relative merits. The inboard helium leak test is the most common test method. The valve or regulator is fully open and all ports are capped except one, which is attached to the mass spectrometer. The leak detector's vacuum pump evacuates the internal cavities to vacuum. Helium gas is sprayed around the part and into leak test ports. The differential pressure from atmosphere to vacuum pulls the helium molecules through the leak path. This method allows the test person to locate the general area of a leak, which is very useful for troubleshooting and does not saturate the seat with helium. The outboard sniffer probe helium leak test is used to test for outboard or external leaks. This method pressurizes the inlet port of the valve or regulator with helium, while the device under test is fully open across the seat. The differential pressure between the part's internal cavity and atmosphere surrounding the part pushes the helium through the leak path, and the sniffer probe vacuum pulls the helium from atmosphere into the detector. APTech tests all mechanical joints and welds. The leak sensitivity is limited by the concentration of helium in the atmosphere, or about 5 × 10⁻⁶, but this concentration varies. The part passes if the sniffer probe does not detect a rise above background levels of helium. This test has the ability to locate the general location of the leak using the sniffer probe. Because this test saturates the seat with helium, it must be done after a helium across the seat leak test to avoid saturating the seat with helium. The inboard across the seat helium leak test method pressurizes the valve inlet with helium and attaches leak detector vacuum to the outlet. As mentioned previously, because valves use polymeric seat material, helium permeation limits the test time. PTFE, PFA, Vespel, and PCTFE test time is limited to 15 seconds. In this example, we are testing a valve because it is not recommended for regulators. Next, we'll explain why. The helium inboard seat leak test is not recommended for regulators because unless you're using a subatmospheric regulator, pulling vacuum on the outlet of the regulator will often open the regulator, breaking the seat seal and exposing the low pressure side to pressurized helium. Vacuum on the inlet is also not recommended because it can cause a leak across the seat. A regulator does have a vacuum inlet pressure rating, but it's intended for purging, inboard testing, and system flushdown only. Unless the regulator is rated for absolute delivery, the minimum rated controllable outlet pressure is always a positive pressure, typically 1 psi G or greater. For more detailed information and discussion of recommended regulator seat leak test methods, please see product note number 422. The sniffer probe across the seat helium leak test method pressurizes a valve or regulator's inlet with helium, and the operator inserts the sniffer probe in the outlet. As mentioned previously, helium permeates the seat material, so test time should be limited to 15 seconds. This test sensitivity is limited to the helium concentration in air, about 5 times 10 to the minus 6. The static pressure decay test is used to detect outboard leaks. Any gas can be used. This test measures all potential outboard leak paths by measuring internal pressure decay over time. The valve or regulator is pressurized and fully open to allow pressure to equalize on the inlet and outlet sides. Therefore, the regulator inlet pressure will always be less than the maximum outlet pressure to ensure pressure is equalized. The inlet and outlets are capped to trap pressure. Temperature changes from start and finish of test will impact test accuracy, so temperature measurement and compensation is required. Many customers perform a static pressure test after helium leak testing, but before system startup. This method does not have the ability to locate leaks. Valve and regulator seat leaks are also tested using static pressure. This test can use any gas and measures changes over time of the outlet pressure in a fixed volume. This test reveals both seat leaks and low pressure side outboard leaks by trapping static pressure. The valve version of this test usually has atmospheric pressure on the outlet. The regulator version adjusts the outlet pressure to a given positive test pressure setting. Test sensitivity is determined by trap volume, pressure sensor resolution, test pressure, and time. Ambient temperature changes over time will also affect test accuracy, so temperature measurement and compensation is required. Many customers perform this test after helium leak testing and also before system startup. Now let's demonstrate the static seat leak test for a regulator. Begin by pressurizing the regulator inlet with nitrogen and trap pressure by closing the inlet and outlet valves. Then set the desired regulator outlet pressure, making sure there's a pressure difference from inlet to outlet. After pressure adjustment, turn the regulator knob counterclockwise a quarter turn to release adjustment range spring force on the diaphragm. Confirm the shutoff of the upstream valve and downstream valve and monitor for a pressure change, rise or drop. An outlet pressure rise is an across the seat leak. Pressure drop is an outboard leak. Typical test specification is not more than 3 psig pressure rise in 1 hour and or 5 psig in 24 hours. The bell jar helium leak test measures outboard leaks of all mechanical seals and welds. The regulator is placed in a vacuum chamber, the bell jar, and the regulator is pressurized with helium. the leak detector pulls vacuum in the bell jar. This eliminates the background concentration of helium in atmosphere, allowing the much greater test sensitivity. However, this method is not production friendly as it takes time to set up and perform the test. This method also does not allow the location of the outboard leak path to be located and saturates the seat with helium. Now that we've examined the various leak test methods and their merits, we can compare their relative sensitivity and ease of use. The outboard bell jar leak test with 100% helium is the most sensitive, followed by the static pressure test for 24 hours. But they're not easy to perform. The outboard sniffer probe test and inboard helium leak tests are less sensitive, but they're the easiest to perform. Again, a part may pass one or several tests and fail another, which is why multiple types of tests are performed. Just because a part passes one test and fails another does not mean the test was done improperly. It just means that that second test is more sensitive to that particular leak. Let's review a summary of the key information about leak detection. Everything leaks. The question is how much, and is it an acceptable and safe rate? A 10 to the minus 9 leak rate is equal to a sugar cube sized gas bubble every 31 years. Leakage rate quantifies the volume of a given gas for a given time. Helium mass spectrometer leak detectors are commonly used for leak detection due to their sensitivity, helium's non-hazardous properties, and low concentration in atmosphere. Seats are quickly permeated by helium, so seat leak test time should be 15 seconds or less to avoid detecting permeation leaks. APTech only recommends two types of regulator seat leak tests: the outboard helium sniffer probe seat leak test and the static seat leak test. Temperature compensation is required for static leak testing to ensure accuracy. A part may pass one or several tests and fail another, which is why multiple types of tests are performed. For more information about APTech products and technical resources, go to aptech-online.com, where you can download product note number 422, our guide to pressure regulator across the seat leak testing.